So in order to do anything in this question, you need to know your molar masses. So we need the molar mass of propane, and we need the molar mass of oxygen. Melissa, what's the molar mass of propane?
44.11.
Thank you. Okay, you're going to use both of these molar masses. It doesn't matter if you're using it using the formulas or dimensional analysis. We're also going to need, gentlemen, we're also going to need the mole ratio. You're always going to get that. Your mole ratio is based on these numbers in red, your coefficients. Okay? So you're going to need a mole ratio, and you're going to need the mole ratio that compares the substance that you have information about and the substance that you want information for. So who do we have the most information about? You've got 4 choices up there. You can narrow it down to 2. Which one do we have the most information about? C3H8. And which one do we want information for? Oxygen. So those 2 substances are going to be in your mole ratio. So you're either going to have to use 5 moles of O2 to 1 mole of C3H8, or the opposite, the inverted mole ratio. The relationship is the same. We just don't know right now which one we need. So everything you need to know is up there. What is the quantity we're looking for? If you don't know this, when you start your question, you can't solve it. You have to identify what substance we're trying to find information for. Gina? Mm-hmm. We want to find grams of oxygen. We want grams of oxygen. We want the mass of oxygen. So you start, this is dimensional analysis, you start with a ratio that has GO2 in it. Is there a ratio up there with GO2 in it? Is there grams of oxygen anywhere there? Nick?
32 grams per mole.
Yeah, 32 grams in 1 mole of oxygen. Okay? So we're going to use that ratio first. So what we've used essentially first is the molar mass of oxygen. There's 32 grams in 1 mole. So we've got the unit that we want on the top, but we want to get rid of what's on the bottom. When you set up dimensional analysis, you can only do multiplication by ratios or multiplication by numbers. To pick the next ratio, it has to have what we want to get rid of in it. We want to get rid of what's on the bottom because we want grams of O2 all by itself. Okay? If we get rid of moles of oxygen, we're left with grams of oxygen. So our next ratio has to have moles of oxygen on the top. Is there any ratio or value up there that has moles of O2 in it that we haven't used yet, Shayna? Yeah, right here. We've got a mole ratio. There's 5 moles of oxygen for every 1 mole of propane. So we've now used our molar mass of oxygen, our mole ratio, and we can actually cancel moles of oxygen, which is awesome. It's gone from our first ratio. But we've now introduced moles of propane. We want to get rid of moles of propane. Is there anything up there that has moles in it and it refers to propane? Shamir?
The 1 mole, the 44.1 grams.
Yes. We know that we've got this molar mass of propane. It has 1 mole of propane in it. So when we set it up in the next step, the mole of propane has to be on top because we want it to cancel this. The next ratio that you put in always has the previous bottom portion on the top. Here we had moles of O2, moles of O2 was on top. So now we need moles of propane on the top. So 1 mole of propane, 44.11 grams of propane. I've just used the molar mass of propane. That's all I've used. Your moles of propane cancel. We're getting closer. I've got grams of O2, but I've got grams of propane. I want to get rid of grams of propane. Is there a number?
This is WP.
So there has to be a value that we have that's got grams of propane. 10. We've got 10 grams of propane. The trick here is in writing all of your units in until you get adept at doing this. So you have to write in mole in your mole ratio. You have to write mole in your molar mass. Okay? So here we go. Grams of propane are finished. Now if you look at that, the only unit that we have left is grams of O2. So 32 times 5 times 10 divided by 44.11 will give you grams of O2. So try it. Put it in your calculator. And we know that there's 6.02 times 10 to the 23rd molecules in every 1 mole. Is our chemical equation balanced? So we've got to balance it first, right? 2 molecules of water make 2 molecules of hydrogen and 1 molecule of oxygen. So, can you identify what we have to find in the question? Okay, now that we've identified what we want, let's look at what we've got and see if we can get there using the numbers that we have. Is there anything up there that actually has molecules already in it? Avogadro's number.
Yes, it does.
So we want molecules of O2, so it goes on top. So our ratio is written the same way as Avogadro's number. What comes next is a multiplication sign. Somehow, we have to go from over here, where we're trying to find information, to over here, where we've got lots of information. How do you go from this substance to this substance? What do we need to use to go from here to here? A ratio. We need a mole ratio. So we need, which substance goes on top? Oxygen, because it's on the bottom of the previous ratio. We want to get rid of it. So we've got moles of O2 and we've got moles of water. So we use our mole ratio to go between two different substances. So our coefficient in front of O2 is a 1, and our coefficient in front of water is a 2. Moles of O2 cancel. But I've got moles of H2O that I've got to get rid of. I happen to have moles of O2. I've got one of them in 18.02 grams. So this is grams of H2O. Wow. You let me just keep going. 25 grams of H2O. So my only unit left is molecules of O2, because grams of water canceled.